we are starting PO61 Part 2, and the only difference, the key difference between Part 1 and Part 2 is that now when we deal with fractions, you're not going to be blessed or gifted those perfect square denominators. We're going to talk about what to do when in a fraction of a root, the denominator is not a perfect square. Emily?
Yep. Yeah, so I shot on that.
No, I do not. Emily?
You need to change up your intro.
I'm happy with it. Mario?
Oh, I'm just strict.
Thank you. Okay, so sometimes you'll find that there's a radical in the denominator of a fraction. This is a problem because what do we know about the root of a non-perfect square as far as rationality versus irrationality? The root of a non-perfect square is what type of number?
Irrational.
Irrational, okay? And when we're talking about a fraction, in order for a fraction to be simplified, the denominator has to be rational. Because if you think about what a fraction is, a part over a whole, you have to have a rational whole, right? If what your fraction is out of is an irrational number, there's no whole there, okay? Because we don't know what the exact value of that number is. So when we call this rationalizing the denominator, it's called that because we're taking an irrational value and we're making it rational. How do we do that? Well, here are the steps, okay? If we have the fraction, and I'll leave the steps up here, please. Or steps up here for you to see. If we have the fraction 5x over root 7, this fraction is not in simplest form because of that root 7 in the denominator. The denominator is an irrational number. So what we do is we multiply the fraction by root 7 over root 7.
Wow.
Why would we do that?
To get a perfect square. To get 7.
When you multiply 5x over root 7 by that root 7 over itself, we pick this number specifically because it's the denominator that we have to fix. When you multiply root 7 by itself, you get root 49. What's root 49? 7. Now the denominator is rational.
But it doesn't change.
Okay.
Because 7 squared. Yeah, it's 1.
Yeah, and the best part is, we didn't change the value of this fraction, because what is root 7 over root 7 equal to? 1. Anything divided by itself is 1, right? And you've multiplied fractions by 1 for a long time. Whenever you simplify a fraction, you've divided by, 3/3, you divide by 1. When you write equivalent fractions, you're multiplying. The numbers change, but you're just multiplying by 1. That's what's happening here. Okay? We are multiplying the fraction by 1, so the value of the fraction doesn't change, but what it does is it turns an irrational number into a rational one. Even though our numerator is now 5x root 7, it's an irrational value up top, that's okay. Okay? Like when we multiply here 5x times root 7, we don't get, root 35, because the 5 is outside the root, the 7 is inside the root, they can't be combined. So it's just left as 5x root 7. And even though that root 7 is up top, that's okay. It's okay for a non-perfect square to be in the numerator. It is not okay for it to be in the denominator, because the denominator represents the whole. Mario?
It's 5x. Is that the final answer?
Yes, this is the final answer here. 5x root 7 over 7.
Oh, so
Is the
that's
final
the
answer.
easy.
Okay? So, let's just start practicing a little bit here.
You can just do the bottom version.
We have 2
That's it.
over root 3. We have to rationalize because that root 3 in the denominator is a problem. So what are we going to be multiplying our fraction by?
3.
James?
3.
Not 3.
3 squared.
Not 3 squared.
Root 3 over root 3.
Root 3 over root 3.
Wait, why did I say James' vocabulary was
I don't know.
Okay? You said a lot of good things, but not quite the right thing, right? And the reason why we're multiplying by root 3 over root 3 is because in our denominator now, root 3 times root 3 is root 9. And what is the root of 9? 3. Right? It's no longer an irrational number. Okay? In our numerator, 2 times root 3, it's not going to be root 6 because the 2 doesn't have a root around it. We can't combine them. It's just going to remain 2 root 3. So 2 root 3 over 3 is our answer. Evan?
For this type of equation, does the denominator number stay the same, but you just don't want the root?
Essentially what happens is the root just drops off and the number stays the same, yes. The reason why that happens is because, like in this case here, root 3 times root 3 is root 9, which equals 3. Okay? We're essentially taking, another way to think about this, and this is an argument in support of PEMDAS, so if you're still a PEMDAS person, I'm about to chip away at your belief just a little bit here. But if we square the root of 3, which is what we're doing here, because we're multiplying root 3 times itself, right? We're squaring it. Like we've seen before, a root and an exponent do what? Cancel out. We're left with just 3. Okay? The R belongs. When you go out to high school and you're challenged by your peers and even your teachers, you remember you are part of my army. What? Hold on, I think it's this one. Okay.
Probation nation.
Yeah.
That should be a bunch.
That should be like a bumper sticker.
That's so bad. Okay, I really shouldn't be laughing, but it's kind of
It's
funny.
just kind of funny.
Okay, 9 over, once you learn to laugh at yourself, you're guaranteed a lifetime of entertainment.
Wow, you laugh at yourself a lot?
9 over root 5, what are we multiplying by to rationalize this? Root 5 over root 5, right? 9 over root 5, multiplied by root 5 over root 5. What do we get in our numerator?
10. 9.
Our numerator, Emmett.
25.
No, our numerator, Emmett, up top. Think up top. Luca.
9 radical 5?
9 root 5.
I just want to say
It's a little
radical.
radical.
9 radical 5. Same thing. Emmett, what's root 5 times root 5?
25.
Root 25, which equals 5, right? Root 5 times root 5 equals root 25, which equals 5. We've rationalized. We can't cancel out this root 5 with this non-root 5 because they're not the same value. It's tempting, but they're not the same value, and so we are finished. Yes?
Do we have to show our work at this?
Yes. Okay? Let's go down to one where rationalizing sometimes actually helps us out. And I'm looking at that 12x over root x piece here. Okay?
I want to see how you do the 6, 3.
We've got 12x over root x. We've got a variable. That's okay. What are we going to be multiplying by here? Yes. Over root x. Even root of a variable over itself is still equal to 1. We're just multiplying this original fraction by a really funky version of 1, but it's okay, because you can multiply anything by 1 and not change the value. And so what happens here is, root x times root x is root x squared, and as we learned in the first part of PO61, root x squared is a perfect square, it equals x.
Oh, yeah. Oh, just equal.
Okay? Hugo.
But what if x is 0?
If x is 0, the root of 0 is 0, and you end up with 12 times 0 over 0, 0 divided by 0. X is not 0.
What's 0 by 0?
So now we have in our numerator 12x root x, right? Because we have the 12x times the root x. But we're not done yet. Why are we not done yet? In
Because you
this
can
case.
cross out the x's.
Because here, whatever x is, I have x over itself.
So it's just 12?
It is like PO15, whoever said that, yeah. And so ultimately now, what we're left with, our denominator cancels out, and we have just our numerator, 12 root x, and that's your final answer. So in this case, it does kind of make the overall expression simpler, okay? We're allowed to completely eliminate that denominator. Christopher?
Wait, so is every one gonna be the numerator and the denominator are up top, together, and then the denominator is just the denominator on the other one, but it's not squared.
Pretty much. That's the basic gist of it. When you start dealing with more complicated expressions, that can be kind of tough to follow because things will cancel out or things will combine in weird ways. But that's the general gist. Yes. Okay. Yes. Let's go to 2 root 10 over root 80.
What about 6? You 6.
Which one?
6
over. We just do.
I'll do one of these. Which one do you want to do?
Oh,
I don't think we have time for both.
The last
I
one.
think we did.
I'm offering one.
Last
The
one.
last one?
I want to know how to do it.
I will. We'll do the last one and see if that helps with that fourth one. I'll take it.
I'm about to say Mr. Schultz.
Nope, that's.
I know. Hi, Mr. Robinson. Hi, Mr. Robinson.
Who has an idea of what we could do first with this one here?
Probation. That was probation.
That was. He's a charter member, yeah.
He's on the board.
James.
You can do the exact same thing. That
Well-
we're doing.
Can we make our numbers a little more smaller and easier to manage here?
No. Yeah.
Oh, divide by 10.
Can you cancel the roots out?
We can't cancel the roots out, but we can simplify, right? Because this 10 and that 80, they're both underneath a root.
So I can go 1.
Root 10 over root 80 is equal to root what over root what?
1 over 8.
1 over 8.
1 over 8. So now we go 8.
And the nice part about that is that if now we have 2 root 1 over the root of 8, what do we know is true about 2 times the root of 1?
Still
It's just irrational.
It's just 2. What's the root of 1?
Oh,
What?
1, right? What times itself equals 1? 1 times 1 equals 1. So now we can break this down even further
Wow.
to be 2 over root 8. Okay?
Yeah, it's pretty simple.
Now what do you want to do?
That's it. 2.
What's that?
That goes down even more.
Okay, so now Tatum wants to multiply by root 8 over itself. Here's the rationalizing step. Okay? And because, now that's going to give us 2 root 8 over the root of 64, essentially, right? Root of 64 equals 8, like we've seen before. That root just kind of canceled out. We have 2 root 8 over 8.
Yeah. Don't you just
No, it doesn't.
do anything except
Oh
add the
my
denominator
god.
up?
Essentially,
You can
yes.
simplify it,
Basically,
right?
yes.
You can't.
What can we do next, James? Are we done?
No, you can
No.
simplify it.
What can we simplify?
8 and 2. 2 and 8.
We can simplify the 2 and the 8 to be what?
1 and 4.
1 and 4, or just root 8 over 4, because the 1 doesn't have to be written, because anything times 1 is just... Are we done?
Yeah.
No. Wait, can we do the
Please.
oh, wait, never mind.
What else can we do,
Can
8?
we please be
Oh, we can multiply, no, not divide the 8 and 4.
We can't, because the 8's got a root with it, the 4 doesn't. What else can we do?
Is that like
Nothing.
That is not the correct answer. There is
Oh,
something.
multiply by 4.
Multiply by 4 isn't going to really help us.
You could do that
What's that?
Just take
We did that. We did that here. Root 8 times root 8 is root 64. That gave us 8 here.
what is this like monstrosity?
We can simplify the root 8, because root 8, Jonas, has perfect square factors, right?
No, give me 4 too.
The root of 8 can simplify to be root 4, or rewritten, to be root 4 times root 2,
Which can be rewritten to
2 root 2. 2 root 2.
2.
which means our numerator is now 2 root 2 over 4.
Now we simplify that.
Now we can simplify again.
Oh my.
Now how can we simplify?
The 4.
Root 2 over 2.
Not root 2 over 2.
bunch of equations like
Oh, you divide by 2.
We can simplify the 2 and the 4 to be 1 root 2 over 2, or a final answer of 2 over 2.
This can be like
Okay.
a question.
Now,
Are these gonna be like typical questions?
this will be a typical question in Algebra 2.
Oh, okay.
Okay? This is not going to show up on your test, one with this many simplifying steps. However, it will be a basic question in Algebra 2, especially those of you that go the honors track, okay? So, but you always have to be looking for, and it's, the math itself, like you could do this entire thing without a calculator, right? The math itself isn't what's challenging, the calculation piece. It's how can I combine, how can I break down, how can I simplify, and that's where, you know, number sense is a pretty important thing. So, this one is kind of similar to that one in the sense that there's multiple avenues you could take. Can you simplify first? Should you rationalize first? Kind of what to do here, okay? If it were me, I would take this and I would look at this 6 divided by 3 first.
Yeah, I've already done it. So, complete.
Okay.
For you.
2-1. Labor progress.
Alright. And then I don't want you to do the very bottom section. We'll do that in class tomorrow since it's a math day anyway. So just this top section here for homework. These 8 questions, we've done 4 of them. You have 4 of them to do for homework, and that's going to be due tomorrow. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on this?
Congratulations on making probation.
Thanks, Tim.
Mr. Robinson is president.
No, Miss Dawson.
With gusto, that's how you math.
Don't forget
Like and subscribe.